Good morning, good afternoon, everyone, and welcome to today's QAQC and testing webinar. My name is Stephanie Cox, Director of Business Development for Enertus North America. Thanks everyone for joining. I know that the start of the year is always a little hectic and chaotic, so we appreciate everyone's time nonetheless. Before we get started, I have just a few quick logistics to cover per normal. Attendees are muted, but our chat box is hopefully functioning just fine. So if you have any questions, feel free to type them in the box and we will have time at the end during a Q&A session to go over any of the items. We'll also be providing our contact information. So if we need to do any follow-ups, feel free to reach out to us there as well. Last item, the webinar is being recorded. We should have the recording available probably early next week or so. So we'll send that out via email and it will also be available on our YouTube channel. Thank you very much. So for those of you who are not familiar with Enertus A+, we are a global consulting, engineering, and quality control firm for renewable energy and storage projects. Enertus has been established for over 15 years and has provided services on more than 250 gigawatts of solar and 12 gigawatt hours of storage across over 4,000 projects worldwide. Our parent company, A+, is one of the world's leading testing, inspection, and certification companies, and they have over 23,000 employees across 70 countries. So together, our companies leverage technical expertise and shared knowledge across all energy sectors throughout the world. To kick us off, I wanted to take a quick snapshot of the U.S. energy market today. So, as we all know, the U.S. is set for rapid growth in renewable energy projects. This graph right here is EIA's graph from last month, which demonstrates the installed growth projects for the U.S. market. So it's roughly 55 gigawatts or so of new U.S. generating capacity set to enter the grid this year. So those are some large numbers that we're working with. When we consider the why behind this boom, we can attribute a couple of major factors such as the IRA and delayed projects due to the Uyghur Forced Labor Prevention Action. The mix of the long backlog plus incentive-based opportunities provides a pathway for a lot of new projects to come online. All that's certainly exciting in terms of growth, but when I think about all the materials and supply that we'll need to keep up with the demand, that gets just a little scary. So while prepping for this webinar, I was scouring through 30 days worth or so of press releases, and there are a handful of articles on new suppliers, new materials, X company announcing a new factory build. So a lot of great activity. Diversification of materials and newcomers in the market is great for supply chain and diversity and certainly promotes innovation, but it makes me wonder, at what expense are we rapidly deploying these projects? As an industry, I do hope that we focus on proper practices, start to lean into supply chain traceability, and really just hold all parties involved accountable for efficiency. So I think this webinar is very fitting for all these topics to help address the unknowns. All that being said, I'm excited to share with you some insight on how to best protect your projects, and we can share that through this webinar. So now it's my absolute pleasure to introduce today's presenter, James Whittemore. He is our Senior Manager of QAQC and Vendor Inspection Services for North America. James has over a decade of experience of PV manufacturing. He has contributed to the startup and stabilizing of 3 US-based PV factories, which have yielded production of over 2 gigawatts of PV modules. He also has vast experience as a process engineer at both a thin film factory and a 400 megawatt factory of a tier 1 module supplier. James is a Floridian, so if you see him bundled up most of the time, please don't judge. Most importantly, James also has some of the best dry humor I've heard, so I hope you all get the chance to talk with him one-on-one someday. Thanks again for taking the time to join us today, and we really hope you enjoy this webinar. Over to you, James.
Thank you very much for the kind introduction, Steph, and it's a lot to live up to, so I will try my best to provide you with some dry humor. But first, we'll start with a quick dad joke. So The best defense is a good offense is a nod to the big game that's coming this weekend on Sunday. For everyone who's not aware, it's American football. It's the big game, but because the main organization that's hosting that game is really litigious, we can't say the actual name, but we'll say it has something to do with a superb owl. And so I want to wish everyone a happy or a good superb owl someday. Now, this idiom is overused. It's used quite frequently in sports and in war. Here's a quote from George Washington in a letter he wrote during the Revolutionary War. And I guess the question is, how does this apply to your PV projects? Well, it's actually quite applicable, because what it is saying is that proactivity, or the appearance of it, that is the strong offensive action. And it is way better than taking a passive attitude. It will protect you. It's the best defense to protect you from opposition, from a counterattack, or just an attack. And I'm not saying that your vendors, your partners are your enemies. I'm saying risk is your enemy. We're saying risk is your enemy. And proactive action is going to protect you from that risk. And that's at the core of what we're going to be talking about today. We'll talk about strategies that make you proactive in protecting you from risk. Now, this simple flow chart is going to be used as our map as we go through this webinar. And I'll talk about how the quality assurance, quality control, technical advisory group, and the testing and optimization groups can help you in each of these phases of your build, starting from pre-contractor development all the way to production and operation. Now, entering the content with QAQC, our team, the resources that we have to execute these strategies are basically mainly our people. So our wisdom, we have decades of experience in manufacturing, testing, and inspections, certifications, building projects, and we use that wisdom to inform our clients, inform decisions, help understand industry standards and risks. And then the boots on the ground, our inspectors, the knowledgeable eyes and ears that represent our clients. We have inspection teams in Spain, US, China, Malaysia, Thailand, Vietnam, India, Mexico, and Cambodia. And we have access through to a vast network of inspectors through our parent company, A+. So we have a global footprint to help out our clients. In addition, we have a third-party independent laboratory that's accredited that we're able to use for quick turnaround on chamber tests or bifaciality tests, IV tests. So these are our strengths. These are the resources we use to execute our strategies to protect projects. Now, entering into each strategy, the contract is arguably the most important strategy to focus on. It is going to define the rules of your relationship with your suppliers, and it helps to communicate the level of risk you're willing to take through the entirety of a project. So paying attention to the technical details is extremely important when you go into contract negotiations. That's why we emphasize getting help early in those negotiations so that you have that technical eye there. I'm gonna highlight two technical details that we find spiking as issues recently, but there are dozens of issues that you need to be looking out for. So this is a pair of electroluminescence images. Basically, it's an X-ray for modules. You put a current through the module, it illuminates IR light like an LED bulb. Take a picture of the module using a special camera, and you're able to see these cracks, which are micro cracks, which are invisible to the eye. So these cracks here that are circled in red, those cracks are the point of contention. So we've seen a number of acceptance standards that have pushed the envelope and started to allow acceptance of cracks below a certain size. So that technically means that every single cell on this module could have cracks below a certain size. And it is very well known in the industry that cracks propagate. A crack represents a defect in a single crystal. Apply strain, that crack is going to grow and grow into some severe branching cracks that cause isolation of a cell. This is going to affect the power performance of a module in the field after stress. So it is important to pay attention to these acceptance standards and the details of the acceptance standards, and then not to fall back and let these small things through. Small things, that seemingly small things that are pretty significant. And then the bill of materials, that represents the ingredients that go into the recipe that make up what you're purchasing. They're extremely important. And we've seen kind of lackadaisical definitions of the BOM in the contracts, and we urge that technical specifics be used when defining your BOM. And that applies to the whole list. But this example is with glass. This is in partnership with the testing and optimization group. So they've noticed on certain projects that we didn't do QAQC for at Origin, that there were some extra sensitive modules where the glass is breaking on the backside. Dig in a little bit more, and the glass actually is not what was to be expected. It was a thinner glass on the backside. And dig in a little more, and the contract actually did not specify what the buyer was getting in terms of glass. All it said was the supplier's name. So the supplier of the glass, so the supplier of the modules felt like it was okay to blur those lines, blur the expectations, change the BOM a little bit, and it resulted in some risk being pushed back onto the client and them having to deal with extra breakage in the field. It's important to define those specs and define them well and hold the suppliers to those definitions. The next item or strategy we want to highlight is supply chain traceability and ESG audits. This is surprisingly a new entry into the industry. Supply chains are typically very opaque, but as a result of the risk of being somewhat responsible for unethical business practices by purchasing supplies from suppliers using those unethical business practices, it's kind of raised the need to provide more illumination to the supply chain. And I think it's going to be something that's applied across multiple supply chains, not just PV. Anyways, we're seeing the need for this now, and it's being used across these three phases: pre-contract, pre-production, and production. However, as the industry begins to grasp with the scope and practice, you start using best practices and illuminating the supply chain, we're going to see this move back to pre-contract or pre-production. And it's difficult now because supply chains are simple but complex. The further you get back from the final component, the more complex they get, because the more variety of raw materials that can go into that raw component. And we find that while the end of the line suppliers might be able to trace their raw materials within their own organization, as they go back, it turns out their vendor qualification procedures are not great. So maybe their vendors are not doing the same. So we think that this is going to be new industry best practice and pretty much will be required in almost every single contract that we see executed. I would be remiss to not highlight some of the other strategies that we think are important in pre-contract, because they're this area where you're defining a relationship is so important. Vendor qualification, where you do research on your vendors, make sure that they're qualified for supply. Technical due diligence, checking out the technical specs of what you're purchasing, and then defining those specs in your RFPs. So make sure you come at these items with a technical eye and expert eye. Next, we are going to talk about the pre-production stage and strategies to protect yourselves in pre-production. One of the main strategies is the pre-production factory audit. And this is simply an inspector going to the factory and figuratively and literally walking through that factory, analyzing the quality management system and seeing that it is being used per industry standards and that it's being executed per procedure. And what results from a factory audit are findings, a list of items that are risky to production. Those findings can range from minor to major to critical. Minor is something that needs to be corrected, but doesn't really imply a risk to reliability and performance. Major is something that it needs immediate action, and it is fairly risky for production. It could impact long-term, medium-term reliability and performance. And then critical findings are something that need to be corrected immediately, and they're a showstopper. They're going to prevent production from happening, and you need to correct them immediately. They could be a safety issue or cause early wear out. So an example of a major finding is this is an HMI of a auto busing machine, and it's using the wrong recipe as compared to the SOP. The benefit of automation is it's quick and repeatable. The negative of automation is that it's quick and repeatable. So if you set it up incorrectly, you make a lot of the wrong thing. That is something that you need to be aware of when you're doing these audits. This is an extremely important parameter that needs to be correct. If you execute this incorrectly, you'll end up making a lot of soldering, potentially making soldering failures that will go in the field. I'll highlight one of these in the testing portion that could affect the power of your modules over time. Then a critical finding, here's an HMI of a high pot insulation tester. And it was found that these probes were not making good contact on the frame. And as a result, everything was going to pass whether or not it should be failed. So this results in potentially modules that will cause ground faults in the field, cause electrocution risk. This is a critical finding that needs to be remedied immediately. And yet, so that's the whole point, to find the big risks in a factory, highlight them, correct them before production starts. So looking at approximately 1,500 of the last factory findings that Nerdist has found in factories, we see that 75% of them are majors, and then 50% of them are related to the SOP. And then if we take this information and turn it into a score, we find that the distribution of that score is skewed to the right. So this right skew means extra risk, means the factory is following is using out of control protocols, or they're not following a quality management system, or not using best practices. So this emphasizes the need for that pre-factory audit. You want to make sure you get in there and identify whether or not the factory you're using is extremely high risk, and then correct those issues before starting, or just reject the factory in general. find a new factory to start production with. Bomb validation testing is extremely important for protecting your purchase because of this is somewhat controversial. The certification and testing of materials tends to bring a false comfort level to the bomb being used in production, because that certification and testing is often done really far in advance of production. And so we all know that materials can change, vendors, procedures can change, and that means that the raw materials going into your build can change over the year or 2 years since the certification took place. So it's important to do a bomb validation test before production starts to look for any potential catastrophic failures. One other thing to highlight regarding the bomb and bomb validation testing is how similar all these raw materials can look. These cells actually were made in 2 different factories. They look exactly the same. They're made by 2 different suppliers, still looking exactly the same. And they have different electrical properties and different reliability properties. So this just highlights how easy it is to kind of hide bomb changes. Then if we look at some bomb validation testing, we did over 9 projects for different clients on the same tier 1 manufacturer who is using the same cell model number. We see a wide variety of LID performance. And then highlighting the risk involved in not validating the bomb is these last 2 projects, which the testing was done very close to one another, different factories, but same tier 1 supplier. During the sampling, it was noticed that this near out of control LID cell was done at an OEM factory. We saw in a packaging slip that these cells came from not the tier 1 supplier's factory, but from an OEM who is widely known in the industry, but their performance level was quite different from LID performance of that tier 1 manufacturer. So this just highlights kind of the need to validate the bomb, the need to keep an eye out on bomb definitions, and yeah. Then manufacturing startup oversight is a strategy kind of unique to the US as a result of the Inflation Reduction Act. These are some charts showing the history of cell and module manufacturing within the US, and a chart showing the price of the resulting products. So I guess this is to say there have been quite a few tries at manufacturing in the US, and the economics didn't work out, and it resulted in shutdown of factories and the loss of warranty coverage. But also, it's not easy to start a factory in the US. And if you plan on signing a long-term offtake agreement with one of these companies starting a factory, and their early deliverables and quality are going to matter to your financial bottom line, it's important to have somebody who's got experience in the start of these factories to be your eyes and ears, to oversee the startup, to make sure that your partner is meeting their commitments. They're going to meet their deadlines, and highlight if they're not early on. That way you can mitigate the risk. Entering into the reduction phase. So one of the main strategies is manufacturing supervision. This is having an inspector in the factory to oversee production, make sure that everything is going per plan. You can see here that we've pulled out the last 1,200 incidents detected by our inspectors, and then filtered them by which ones resulted in module rejects, classified those incidents, and then analyzed the percentage of incidents that resulted in module rejects for each classification. It's no surprise that non-conforming product resulted in the most incidents that caused rejects, but what is surprising is that the rest of them are items that would not be detectable unless an inspector was at the factory to detect. This emphasizes the need to have those eyes and ears to verify your production at site. There's no way you're going to see the use of an expired material unless you're there to see that that expired material is being loaded on the line. Here's an example exemplifying this issue. This was a finding in which our inspector detected an uncertified encapsulant being loaded, and it resulted in they detected that the thickness of the encapsulant changed. This is the certified thickness, 0.7, and what was loaded to the line was 0.5. That seems like a very low risk issue, but in fact, it's quite a high risk. And then please notice how similar these labels are. It's an easy mistake to make. This is a high risk because the lower the thickness of an encapsulant, the higher the stress transferred to the interconnect, transferred to the cell. There's a higher chance for interconnect failure and cell cracking. And so this 0.5 was not certified to that BOM. It's a pretty high risk to transfer to the client, but which was averted. One of my favorite strategies at the factory uses that same inspector, but they use statistical sampling on batches to verify that that batch is acceptable using acceptable quality limits. The samples are selected randomly, and the number of samples are based on the batch size. Retest those samples and make sure that they're conforming. If there's too many non-conforming samples, then that batch can be dealt with accordingly, but it's a proactive prevention of releasing that batch. Maybe it's rejected completely re-inspected, or maybe the batch is accepted with some commercial negotiations. But the point is to detect the non-conformances and highlight them early and deal with them. We also do this test at our third-party laboratory, where we will send a random selection of samples to the lab and retest it. Here's an example where we did that and detected non-conformances above the acceptable quality limit in EL. And we asked the supplier to go and do root cause, and they found that their EL resolution had changed in the middle of the batch. They went and updated the resolution, retested the batch, and found that 1% of the modules in the batch actually had non-conformances in EL. That risk was averted, not pushed on to the client. And then we also encourage chamber testing. Here's an example of potentially induced degradation testing of the BOM for a batch where degradation was found to be above 5%. This illuminates the issue and helps the three parties to decide what the best course of action is to mitigate the risk. Maybe it is a complete rejection of the batch, or maybe it's a redirection of the batch to an area that's low risk for PID, and then the installation procedures are diligently followed to prevent the formation of PID in the field. So next, we'll go into testing and optimization. The testing and optimization group's resources are, once again, their people. I'm really happy to represent them in this presentation. There is a ton of wisdom who have seen a lot of different things, and they have a lot of expertise to execute these strategies. So we'll start with the development side. And why is this important? Well, if you don't project the power accurately in the beginning, then your expectations are not properly set up during development. And our team has a couple of papers under the belts, a couple of presentations at conferences exemplifying their expertise in albedo. Unfortunately, there's no international standard that is accepted for measuring albedo for PV projects. And generally speaking, satellite albedo is accepted. That satellite albedo can be inaccurate because a satellite is taking a large average albedo measurement. And we find in PV projects, there's that heterogeneity impacts the performance in the area in which the project's going to be installed. So our team has led several long-term ground albedo campaigns to better inform the power predictions for albedo in a project. And interestingly, have found that the albedo performance changes over the seasons, which makes sense because the vegetation changes and thus the reflectivity of the ground changes throughout the seasons. This is a good strategy to protect you guys by properly predicting early on the performance of a project. The next phases kind of merge together in terms of procedures used, because pretty much all the procedures are applicable between these phases. But it's important to emphasize that the earlier they're used, the better, because you're lowering the risk. You lower the risk in two main ways. The first is you lower the financial impact of the risk by catching it early. Maybe you can correct it, or if catch it early, you're not having to uninstall a lot of incorrectly installed materials. In addition, you can better assign responsibility. If you're detecting a problem that could have been caused in shipment or installation in operation, it's hard to assign that responsibility, and ultimately that is going to be a legal fight, or the owner is going to have to take or is going to be forced to take responsibility. One of the strongest tests that we use is electroluminescence. We use international standards, of course, and we've talked about EL and the QAQC portion, but I just want to re-emphasize how essentially magical EL is. It can see the future and it can make the invisible visible. So these cracks, you're not going to see them by eye, but with EL, you can see them. This really smart researcher decided to stress a module using mechanical load and then flash that module in each successive stress point, and then show that the isolation detected by EL led to a linear degradation in power performance. So making the invisible visible. And then it's important to note that it can help to see the future. And here's an example of what I mean by that. PID and delamination, there are defects that show them that degrade in a nonlinear fashion. They show themselves, and then there's a small power degradation, and that just increases very quickly. EL is able to see that early on. You can see in potential induced degradation, the power being going down significantly with each successive EL image. And if you're able to detect PID early on, you're able to mitigate that risk, sometimes even correct it. Delamination, here's an example of delamination that was detected early with EL. couple years down the line, this is going to result in some very ugly delamination. And so now the owners can plan for that problem, or if somebody was looking to purchase, they know that they're aware of the risk of that project for degradation down the line. It's also very helpful in illuminating responsibility by taking snapshots of the quality of material through steps of the project. So this helps to assign responsibility. Imagine if you had an issue after shipment, after install, you're in operation, you go do EL, you detect issues. It's hard to see where those, or properly assign responsibility to shipment or installation. So we encourage statistical sampling and testing in post-shipment and post-installation. This allows for proper detection, early detection, and potentially the prevention of damage to your PV project. Here is an interesting case study. If you're a client looking to purchase a project and you're comparing plant A to plant B, you want to know the current status of performance and the potential future status of performance. So these two projects both had no QAQC at origin, and they were analyzed by our testing and optimization group. First for power, and plant A was found to be performing below expectations, and plant B was close to expectations, just not on point. So already plant A is looking pretty unattractive. Then we did a larger sampling by EL, and this helped us to detect near 40% defect rate on our sampled modules. And then approximately 80% of those samples had poor soldering. While plant B had a lower defect rate, and the distribution of defects were somewhat to be expected for a PV project. So this informs the client which project is going to be the most risky, and they can make the right decisions on what to purchase. The poor soldering defect was this guy. This is poor soldering, and this is similar to the poor soldering that could be formed by that auto busing machine running out of control for an extended period of time. Next is thermography. Thermography is extremely powerful. It's a powerful strategy, but you have to know what you're looking for. So our team has been using thermography for a very long period of time. They use that information to inform our clients in making proper decisions and responding properly. Here's an example of a bad connection and BOS detected using thermography. And then aerial thermography is so simple, it's fast, it's inexpensive these days, but you have to know what you're looking for. So the middle defect is very abnormal. It's not commonly seen, but our partnership between the two departments helps us quite a bit, actually. The QAQC department is able to help identify what the root cause of this issue is for the testing department, and then the testing department's detection of failures in the field helps the QAQC department be on the lookout for new failure modes. And so working hand in hand is pretty powerful, and the benefit of this partnership is the partnership with our clients. In addition, if you're not using a calibrated keen eye, you might have missed this PID starting on this module, which is detectable in aerial thermography, but much more easily detectable in EL. So when somebody is doing aerial thermography, it's important to have the right eyes inspecting it after the fact to detect potential failures in the future. Then the seemingly least high-tech procedure for or strategy for protecting your projects is visual inspection. But in fact, we all know it's the most high-tech because it's using humans, smarter than AI in many different ways. So this is an example of the visual inspection of a project. Our team went out there and detected a bit of a problem, and based off of our experience in the field, we were able to highlight this as a pretty severe issue that could impact the performance of the project and the safety of the project. And it turns out that there were some cost-cutting measures that weren't known about, and those cost-cutting measures resulted in quite a costly correction in the end. So here, the important thing is to emphasize that these strategies be used early on. If this is detected early, you prevent or mitigate that risk early. It's less costly. In addition, you need to have an expert eye doing these inspections so that you know the gravity of the non-conformances found. Our team has been in the field for a long period of time. They're very experienced, and we urge you to use them for system verification. If you have doubts in the startup of your equipment, they have quite a bit of experience in just about all the equipment used in a PV project. They can help verify if it's set up correctly, help you to root cause any issues out in the field. Now, finally, the radiant sensor calibration is extremely important because it is your guide to the actual performance of your PV project. If you are not using a well-calibrated sensor, you're gonna be falsely convinced that you're meeting your expectations, or you'll end up chasing a false failure. And our laboratory in Spain that does these calibrations has done a study of the degree of out of whack the sensors are when they arrive to the lab, and over 40 sensors, and they found quite a bit of variability, both in the negative and the positive. Negative makes sense because these sensors are degrading in the field, and they're becoming they're overestimating. Positive does not make sense, right? But the only explanation for this positive distribution is calibrations that are done incorrectly at the beginning. So it's important that you be aware of these potential issues, and you work to calibrate these sensors. Our team can do it if you ship it to our lab, and we use very tried and true procedure where we use about 10,000 single readings to make sure that the calibration is accurate. And then we can do it in the field if necessary. This is a quicker turnaround. You have less risk to damaging the sensor in transit, and a higher availability. So in conclusion, we're here to help, and these are some of the strategies that we've seen executed really well in protecting your PV projects, protecting your purchases, and we would love to take any questions you might have.
Great, thank you, James, for the fantastic presentation. As James mentioned, feel free to put any questions in the chat. We did get quite a few coming through, so I'm just gonna fire them off and have the rest of the team join. We do have our testing team on the line as well to provide any clarification on items. So this question, I think maybe for you, James, it came in during the pre-production factory audit slides that you had. Is information about vendor qualification components qualification available within the constructional data form?
Okay, what can you repeat the question?
Sure. Yeah. I think they're asking about if the vendor qualification or the component qualification, is that available in the constructional data form?
Oh yeah. During certification, there's a constructional data form used for certification, and that specifically is more about, that is vendor qualification of the subcomponents to a certification standard. So that is something that you've got to pay attention to when you're going through verification of the certifications. It is a proof that the ingredients are going to meet certain standards. But I do want to emphasize that often these tests are done way ahead in the future of production, and things tend to change. And it's important to look at that certification CDF with a critical eye, and knowing that maybe the raw materials that went into it are not exactly the same as the raw materials that were used for certification. So yes, it is like a vendor qualification, and it is best practices, and it establishes the foundation that these raw materials can meet reliability or safety standards. But it is only a first step for protecting. Good.
Great.
That is a good question. Yeah, thank you. And it's a good point.
Great, thank you. I did see a couple of questions for our testing team too. Will high-speed EL imaging for 100% in-field inspection of utility scale PV fields, i.e. at commissioning, become available at a reasonable, justifiable pricing?
Okay, I will take this one. Well, we have already made and testing of EL in some plants. The biggest one, 60 megawatt plant, and with the reasonable cost, the costs lower than $3 per module for big inspections. This and we are refining and improving our methods continuously. So yes, I believe that, and we will work for EL to 100% of them. And that we are also developing our EL with drone method. We do have some initial,
Great, thank you.
But today, our massive EL. Sorry, Stephanie.
Nacho, you're cutting in and out.
Yeah.
Well, maybe can I help you because my colleagues, the audio is not working so fine. So I'm Sergio, and the question is about price. No, now 100% in-field inspection is a reality because we have made it. For example, here in Spain is typical. We have experience in a few PV plants. Full inspection is make it, and of course depends of the sampling. No, the price is goes down because you increases the sampling and you improve your technical or electrical equipment. No, so here the point is Energy's team is improving all the time, improving the technical aspects, making different type of EL inspection. For example, my colleagues comments aerial EL inspection, for example, using drones to reduce the cost effectiveness of the project. No, but to answer and summary the question is by now we done. Yeah, so full field inspection in EL is a reality now. So we can have better prices in the future, of course, because I think the competitiveness is there, no? But I think by now we are super competitive making it. So
great, thank you, Sergio. And while we have you too, another question for EL: what is the standard for pass and fail for EL testing?
Okay, can you repeat me the question? What
Sure.
is the standard?
What is the standard for pass and fail for EL testing?
Okay, super interesting question because criteria used to identify defects on EL is not super clear in the market. No, depending where are you, you can use one type of criteria or another. For example, when you buy a PV sample of, for example, 5 megawatts of modules, we use manufacturer criteria, for example, because you are trying to prove the quality of your module. No, but this only work in early stage. Okay, when we are after a post installation, for example, and your module is mounted, you don't have a criteria to know how is the performance or how is your modules, because the manufacturer criteria is only quality of a product. No, you buy a machine and you want how is the quality, no, and do you have a quality criteria? No, here is different. When we are in advanced stage, an artist have his own EL criteria to identify how can degrade to a module in the future. No, and this type of criteria is super important because we have a correlation between the power degradation expected in the future and the type of the defect on the year, and it's different respect the manufacturer criteria. So the answer is yes, we have criteria, but it's different depending on the stage you are. Okay.
Great, thank you so much. James, I think this one is for you. BOM testing before production start. PV cell test. Which lab test does Enertis recommend? Of course, LID. Which else?
Oh, LETID and PID. For sure. Those are 3 really common ones we recommend, and they're quick. So it's something
the general audience.
Yeah, it's something that you can do real quick to make sure that the quality of the materials is still okay.
Great, thank you. I think this is another question for you, James. Do you, and this came up early on, do you think that the Uyghur Forced Labor Prevention Act will continue to be a big roadblock for procuring modules?
Yes, I do. And the further away we get from today, I think the bigger potential risk it is. It seems to have calmed down quite a bit. There's some suppliers who were allegedly detained who are now being released for being outside of the scope of UFOPA, but the implementation remains extremely opaque. And that, I think, is the risk in itself. The opaqueness is a potential political football and a useful one for attacking those implementing the legislation, and that could result in kind of a backlash and extra implementation in the future. So that's worst case scenario. I kind of lean to the worst case at times, but that is a potential, and it's something we should all be aware of. And the best way to minimize that risk is to continue to push everyone to bring light to their supply chains, to make supply chains more transparent. Yeah. So yes, please be very aware. Please set a Google alerts for UFOPA and for your email, because it could change very quickly.
Perfect, thank you. With all the new factories coming online, what, in your opinion, is the biggest risk to projects that we have with all the factories coming about?
Moving too fast, too quick, and having too high of expectations. So if you're not, it's not easy to start a factory. Let me tell you that. Even in an area that has a lot of factories, it's not easy. You have to build new talent. You have to build your talent pool and train them. You have to establish processes. You have to start up new equipment. Sometimes you're forced to use new equipment. There's a lot of risk in building, and it makes me nervous. So it's important for everyone to be alert, be aware of that, and try to mitigate those risks through proper strategies. Just you got to know it's there and try to prevent it from happening.
Let's see that this one I think looks like for our testing team. How much deviation can there be on the PR measured on a PV plant due to a lack of calibration of irradiance sensors?
Well, I think I can answer these questions. Deviation on irradiance sensor, recalibration must be done between 1 and 2 years because deviation of the sensitivity of this type of electrical components can be huge. Okay, depends of the manufacturer, of course, but we have experience knowing about minus and plus 3% of the deviation on the irradiance measurement. So here the point is irradiance, there is a linear correlation between irradiance and the power production of your solar plant. So the important thing here is if you reduce the error of this type of sensitivity, the error of the performance ratio of your plant reduced too. So performance ratio could be have error values between 1 and 3% because this type of non-recalibration of the sensors. So.
And another question on deviations too. Are there a large deviation between criteria and defect classification on international standards and real defects found in the field?
Okay, if I understand well the question, the deviation is not a number in this type of testing because it's a quality and non-quantitative testing, no? So we have a non-number or value to reproduce this, no? So the deviation is between if I find some type of defects in some type of criteria or another. So here is very problematic because depending of your manufacturer, you have EL defects in your criteria or not. So on the earlier stage, of course, when you use manufacturer criteria, depends of the manufacturer only because it's comes from the negotiation with the manufacturer. But in more later in the PV project, when do you use the NRTIS criteria, for example, we have the most common EL defects found in our experience because there is a relationship between power degradation or power loss and EL defects. So you don't have this deviation because we include a lot of defects finds on the field with our experience in quality control in origin. So we don't have this deviation about the standards or another because we produce our own criteria. Okay, so it's super important in this question because this is the reason because NRTIS have his own criteria. Because we think it's useful for the clients and produce some clear answer for how could be the power degradation in the future of your plant. No? So.
Perfect, thank you. And I think we have time for one more question. And James, I think this is for you. Are there currently any standards in place for ESG traceability or new technology that you're aware of that's helping to track this, or is this for an IE, OE type of situation?
Technology to track. There are a couple of technology startups helping to track, and I think they tend to be expensive. I don't think they've had volumes or a decrease in price based off of the scale. And then standards, there's the SIA standard that was established 2021, I believe. And then there's an ISO standard for corporate social responsibility that I think is important for these manufacturers to use as guidance for their own internal procedures.
Great, thank you. And we did see a few other questions. I want to be cognizant of everyone's time. We had 3 other questions we couldn't get to, so we'll make sure to follow up with those individuals directly to answer those. And I think that the last question, James, this might be pretty tough, but who do you have favored in the Superb Owl on Sunday?
The Superb Owl, yeah. So I live in Jacksonville, so I'm a Jaguars fan. They killed us. Kansas City killed us, even though their quarterback was injured. So I have to root for the team that beat my team, Kansas City.
Oh man, well, go Eagles. So anyways, thank you everyone for joining. Our contact information is available on the screen. We will also be sending out a recording of this webinar likely early next week, as mentioned. And again, we'll follow up directly with additional questions. So thanks so much for your time, and we'll look forward to seeing you at the next webinar. We'll also have people out at Intersolar next week and the Boston trade show the week after. So hunt us down and we can chat some more. Thank you so much.
Thank you, everyone. Thanks, Steph.